Welcome to the Optical LAN Advanced Procedures video, Configuring Policy via Radius Authentication. This video is part one of a series that will define how to set up the system to use NAC in conjunction with Radius Authentication and 802.1x to define the services or policy on a user port. The topics covered in this video include an introduction to the concepts involved in Radius and an explanation of the function of the Tellabs NAC profile application. 802.1x authentication involves three parties: a supplicant, an authenticator, and an authentication server. The supplicant is a client device, such as a laptop, that wishes to attach to the LAN. The term supplicant is also used to refer to the software running on the client that provides credentials to the authenticator. The authenticator is a network device such as an Ethernet switch or wireless access point. And the authentication server is typically a host running software supporting the Radius and EAP protocols. The authenticator acts like a security guard to protect networks. The supplicant is not allowed access through the authenticator to the protected side of the network until the supplicant's identity has been validated and authorized. With 802.1x port-based authentication, the supplicant provides credentials such as username, password, or digital certificate to the authenticator, and the authenticator forwards the credentials to the authentication server for verification. If the authentication server determines the credentials are valid, the supplicant is allowed access to resources located on protected sides of the network. In addition to authenticating the user, Radius can supply various TLVs that are acted on by the authenticator. It can pass back filter ID, which typically defines policy for the port. It can also return identification of the port in the form of an if alias. The Radius server can also define the VLANs in use on the port. For example, each floor of a building can have two VLANs, one for data and one for phones. These VLANs are specific to a geographic location, but logically there's a phone and a data VLAN per floor. In the EMS, all ports on each floor could be assigned with a NAC profile with all VLANs used on that floor. Local policies can then be used to assign profiles to ports within a facility or geographic region. The actual policies within our policy engine can then be generic and would rarely need to be changed, even when adding new facilities. When using profile match, the syntax is TLAB profile match and then the service profile name prefix. The service profile name prefix is a substring used to match the beginning of the profile name. For example, ports on floor 1 might have a service profile data floor 1 assigned to them. Ports on floor 2 might have data floor 2, and so on. Each profile will call upon the appropriate VLAN for the floor. The policy engine would simply send TLAB profile match equal data, and it would match the data service profile for all floors. This allows the policy engine to profile the device and then use generic policies that are not aware of specifics of a particular area. The profile ACL syntax is used to assign an ACL profile to the port to identify the port to allow filtering of the traffic. Here the service port will use the ACL profile that matches the name in the filter ID. The if alias syntax is used to assign a user label on the port for identification. This will be displayed on the EMS whenever a dynamic assignment has been made to the port and is a convenient way to use the NAC appliance profiling to identify the type of device on the port or even the user on the port. This will also appear at the SNMP interface to identify the port. This concludes this video. In it, we have discussed an introduction to the concepts involved in Radius and an explanation of the function of the Tellabs NAC profile application.